Hi, good day, everyone. We're just going to continue on with lesson 2-2. Where we left off on this lesson was we were talking about basically an inequality statement where we had to graph it out and then shade this region, okay? So in the last video, we basically ended it right in this position where we graphed it out using standard form graphing, and then we shaded all the lines out as we see here. From here, what we want to do is kind of go a little bit more in depth with the problem. We got to understand what a lot of this stuff is telling us, and a lot of this stuff is really explaining to us. The one thing I do want to bring up is this whole idea of what does a shaded region really mean, okay? If we notice this graph right here, we basically have two areas, the non-shaded and the shaded, right? This line splits this graph into two different parts in which we can clearly see that one half of it's shaded and the other half is not. The big thing we talked about in the last lesson was we always have to kind of look at these as specific values. An inequality doesn't mean we have to have set specific answers, okay? An inequality could be many different types of answers. There's many different possibilities that could fit that statement. We're not trying to equal a value, we're trying to be less than or greater than a value, okay? So anything in the shaded region is considered to be a less than value, okay, to make the situation work. So I always call this, if we shade it, these have to be correct statements. Any coordinate or any meal ticket combo within that shaded region has to be correct. While over here, this is the greater than. Okay, this, in this current situation, has to be our incorrect values because I'm looking for a less than statement, right? So that's kind of the very first thing I want you to think about. Now, within these problems, we're going to kind of be talking about a couple things today, because here's kind of the big thing you want to think about. There's always going to be these certain things called constraints. Okay, in a real world type of problem, there's a lot more like logical things that stop us from getting specific values, from being able to get specific answers, things like that. Okay, for example, one of the ones the most common is like whenever you deal with a problem with time, well, you can't have a negative time. You can't go back in time. At least we can't do that right now. Okay, so if you think about it, we always have a constraint where we can't have a negative time. It's kind of like in math where you can't have like half a person. You can't have, the one we talked about in this lesson, we can't have half a ticket, right? So we have these specific constraints that causes us to get very specific answers, but within a broad source of them. Well, within this particular problem, what we want to start to do is build these things called constraints, okay? Well, when I want to build constraints, this basically is telling me the restrictions on the problem itself, okay? These are specific things that I have to add into the problem to make this thing work or to make more sense of this, okay? Because, for example, if you kind of thought about the problem from the last time we watched the video, he has $100 per ticket and it's $40 per meal. Well, he can't go and spend all of his money on tickets because then he'll starve. He can't go and not eat for 7 days. See what I'm saying? So we have to play constraints on this to basically state like, I have to do this, I have to do this to make this situation correct. So for this first one, it says, Roy eats lunch and dinner the first day. On the remaining 4 days, Roy eats at least one meal, but he never eats more than 3 meals. So what they want us to do is basically build a constraint, all right? Well, first and foremost, we're dealing with meals here, right? On day one, we know he eats 2. It's an easy day one idea. On day one, he gets to eat 2. For the other 4 days, so between day 2 through 5, Roy eats at least 1 meal each day, but he never eats more than 3. So what I want to do is try to think, what's the minimum and the maximum amount of meals he could have? Well, if he only eats 1 meal a day, the minimum has to be 4, because it's 1 meal for every day that he's there. Versus the maximum would be how many total meals could he have in 4 days if he ate 3 meals a day? Well, it's just 4 times 3, or 12. And the reason I did this now is because I can combine these together. So now if I'm trying to think of how many meals, so day 1 through 5, what's the most amount of meals he could have? Well, he could have up to 6, the minimum amount of meals he could have would be to 6. The maximum he could have is 14, because it would be 2 plus 4 to give me 6, and 2 plus 12 to give me 14. Well, now my last step here is to try to think, how can I create that into a constraint? Because all I have is 2 values, okay? And in my head right now, I'm thinking, okay, the minimum I can eat is 6 and the maximum I can eat is 14. But those aren't answers. Those are just restrictions for me. I could have 7 meals, 8 meals, 9 meals. All those situations would work because it's in between those values. So what I need to do is build a constraint here. How we do this is we have to assume the meals can be in the middle of this. The extreme to the left would be 6, the extreme to the right would be 14. But I can get any value in between that. So what I could do is I could say m has to be greater than or equal to 6. But m also has to be less than and equal to 14. By writing that statement out, I've created a constraint on my meals, basically saying I could be 6 or greater, but I can be 14 or less. So it allows me to be in that area of 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? So I've created a restriction for my meals. So if we're talking about the constraints over here, the first one is my meals have to be between 6 and 14. So let's go ahead and talk about the next one then. There are only 10 performances playing that Roy actually wants to see while in New York City, but he may not be able to attend all of them. Very realistic, right? If you're going to go see a show or something like that, if you're going to go out, if you want to go see a movie or something, you kind of narrow it down to the ones you want to see. But if you don't make it, it's not the end of the world. So I got to make a constraint on this. Well, this one is pretty easy. This one's pretty straightforward, right? We have basically 2 different options. We could see 0 plays, or we could try to see all 10. That'd be like the best case scenario if we got to see all 10. Well, how would we create this in a constraint? Well, I would take my value of the tickets. It has to be bigger than or equal to 0 performances seen, but I can't be greater than 10. So what I've done there is I've also created a constraint. Now, a lot of you are probably wondering like why I did the 0 value here. Okay, and this is where it gets kind of specific. If I just wrote this, technically I'm saying any value less than 10 works. Okay, well, unfortunately, you can't just keep going lower and lower. Eventually you'd get like 2 performances, 1 performance, 0 performances, -1 performances, -2 performances. Okay, you see what I'm saying there? Where I go from this point where it's like I can be less than 10, but if I don't restrict the other side of it, it just goes on forever into values that are impossible. I can't see negative performances. So what I need to do is I need to create another restriction on myself by adding that 0 value in there, basically stating that I can go down to 0 performances at the lowest, but my max is 10. So my second constraint here is 0 up to 10 tickets. So let's see, Roy wants the number of meals that he eats to be no more than twice the number of performances that he attends. Okay? Once again, you kind of read that one out. Roy wants the number of meals that he eats to be no more than twice the number of performances that he attends. Okay? Well, the idea here is that basically, if I'm trying to think about how would I actually solve this, I'm trying to think about this in like the actual sense of it. Sometimes when you throw numbers out, it makes a little more sense. Roy wants the number of meals that he eats to be no more than twice the number of performances that he attends. Okay? So basically that means if he has 10 meals, he wants 5 tickets or 5 performances. Okay? If he has 5 performances, he wants 10 meals because that's twice the value that he had. So what I want to be able to do is basically, okay, if I take 2 times my meals, that cannot be, so it has to be less than or equal to the amount of performances I see. Okay? So now that would make sense. If I want 7 meals, then I can have up to 7 tickets because that would give me 14 meals for every 7 tickets, right? So there's our other constraint, 2 meals to our tickets. So now, in this last one, basically I want us to organize all these different values. And so what this really means, and we really don't have to graph this out, I just want to kind of look at all the constraints and how this affects the problem. If we look at all this out and how this actually works out, if I were to actually write these all out in a single situation, all of our constraints would be these three values here, and we can't forget about the original constraint in the first place, our actual equation for these values. Okay? And what we have done is we've actually built constraints with this problem. Okay? Now, in class, we'll be talking about how to graph two separate inequalities. Okay, we'll actually kind of go through on how to graph this out. I figure this should be a good portion to end the video for today, just so we can kind of just talk about the basics of developing the equations. And then tomorrow, when we actually go through the actual lesson itself, we'll talk about how we're actually going to graph these out and shade and things, okay? Besides that, have a great day and see you in class tomorrow.